Today we're starting chapter 6, which is our chapter on sequences. And a sequence is just an ordered list of numbers that most of the time form a pattern. So it's just a list of numbers. Most of the time they have a pattern involved, and what we're going to be doing is we're going to be trying to find the pattern or the rule that creates the pattern. A finite sequence has a limited number of terms. In other words, it has an end. An infinite sequence has an unlimited number of terms. This sequence will go on forever and usually will be indicated by a dot, dot, dot at the end of the sequence. Now, a term is each number in the sequence. So if I have a list of numbers, each particular number is called a term. Now, its notation is a little bit different than anything you've seen before. A notation for each term is A sub n. So the n is a subscript. It's below the line. This n represents the term number. In other words, is it the first term? Is it the first number? Is it the second term? Is it the second number? The third term, so on and so forth. All right, so what I've done is given you an example of a sequence, and the sequence is 5, 8, 11, 14, and it keeps going from there. 5 is the first term, so its notation is A sub 1, because it's a subscript. 8 is the second term in the sequence, so his notation is A sub 2, or a subscript of 2, indicating that he's the second term. 11 is the third term in the sequence, so his notation is A sub 3. And 14 is the fourth term in the sequence, so his notation is A sub 4. What we're going to be doing is comparing the number itself, the actual term, to the term number. Let's take a look at another example. I've got a sequence 2.5, 5, 10, and 20. The first term is 2.5, and his notation is A sub 1 for the first term. 5 is the second term. His notation is A sub 2. In other words, the second term. 10 is the third term. His notation is A sub 3. And 20 is the fourth term. His notation is A sub 4. Now, when we work with sequences, what we do is we finish the sequence, we find the next several numbers, or we create the sequence using a rule. When we use a rule to create a sequence, there's two different rules that we can use. One is called the explicit definition, and the other one is the recursive definition. They're both rules to create a sequence, but they work in different ways. An explicit definition is a rule that relates each term to its term number. In other words, if I were to look at the sequence that we just saw, how could I relate the term number, to the number of the sequence 5? How could I relate the 3 to the 10? That's what an explicit definition does. It connects the term number and the number itself. The recursive definition is another rule that relates each term but this time instead of relating it to its term number, it's going to relate it to the previous term in the sequence. So it's going to relate each term to the previous term, the one before it. What the recursive definition is going to do is that's going to compare how does the 10 relate to the 5? How does the 20 relate to the 10? Now, as we go through the chapter, I'm going to be asking you for both recursive and explicit definitions, and you're going to be using both explicit and recursive definitions. What we're going to do is we're going to start off using sequence notation to find the sequence. So what happens if I don't give you the sequence and you have to create it? Okay? All right, we want to find the first 5 terms in the sequence, and what I've done is given you the rule. Since we want to find the first term, in other words, the first number in the sequence, I want to find the first term. So I'm going to label that as A sub 1. What I want you to notice now is that the n is now a 1. So what I do is I substitute a 1 in for n in the rule. So A sub 1 is 6. In other words, the first number in the sequence is 6. Now I need to find the next number in the sequence, so I need to find A of 2. That's the second term. Again, notice that the n has now become a 2. So in the rule, my n is going to become a 2. So A sub 2 is 7. So my second term of the sequence is 7. Now, I have the first term, I have the second term, now I need the third term, so I'm looking for A sub 3. My n value is now a 3, so I'm going to substitute 3 in for n, and A sub 3 is equal to 8. Now, the nice thing about sequences is because most of the time they form a pattern, once you see the pattern that's being created, you don't have to continue on substituting into the rule to get the rest of the numbers. If you look at this sequence, I have 6, 7, and 8. If you were to guess what the next number would be, it's probably going to be a 9. Let's check just to make sure. 9 is the fourth term, so I want A sub 4. This time, the n is a 4. So I substitute 4 into the rule, and I get A sub 4 equals 9. So now I know my pattern. Each number in the sequence is going up by 1. So to find the fifth term, I just add 1. So the first term is 6, the second term is 7, the third term is 8, the fourth term is 9, and the fifth term is 10. Because I'm taking this rule and finding each term independently of each other, this is an explicit rule. This rule is talking about the term number itself rather than the one before it. Let's take a look at another example. Number 2, what are the first 5 terms of the sequence? And again, I'm giving you an explicit definition. Now, I'm looking for the first 5 terms, so where I want to start is the first term. So I'm looking for A sub 1. Notice that the n is a 1. So in the rule, everywhere I see an n, I'm going to substitute a 1. 1 over 1 plus 1. And now we simplify. A sub 1 is 1 over 2. So the first number in my sequence is 1/2. Now I need to find the second number in the sequence. So now I need to find A sub 2. This time the n is different. The n is a 2. So everywhere I see an n in my rule, I'm going to substitute a 2. So 2 over 2 plus 1. And now I simplify. 2 over 3. So the second term in my sequence is 2 over 3. Now I need to find the third term in my sequence. So I need A sub 3. And everywhere I see an n in the rule, I'm going to substitute a 3. So I'm going to have 3 over 3 plus 1. And simplifying, I'm going to have 3 over 4. So the third term in my sequence is 3 over 4. Now again, once you have a couple numbers, if you can start to see the pattern of what's happening, you don't have to keep using the formula to get the rest of the sequence. If you look at each one of those numbers, try to see a pattern in each one of the fractions. What I'm noticing is that the numerator is going up by 1 each time, and the denominator is also going up by 1 each time. So I'm going to guess that the fourth term is going to be 4 over 5. What we can do is use the rule to check that. The fourth term is A sub 4. That means that n is 4. So 4 over 4 plus 1 is 4 over 5. So to find the fifth term, all I need to do is add 1 to the numerator and add 1 to the denominator. So when we're looking for the sequence, we're going to use the rule to help us find it. The rules are all about substitution, substituting in the ends. Now, number 3's rule looks a little bit different because number 3 starts off saying that A sub 1 is negative 2. They're giving me the first term in the sequence. The first term in the sequence is negative 2. This is called a recursive rule. Anytime the rule starts off giving me the first number in the sequence, I know that that's a recursive rule. Recursive rules always have 2 parts to them. The first part is the A sub 1, the first term, and the second part is the rule to find the rest of the terms. Now this time I already have the first term, now I need the second term. So I'm going to use the second part of the rule to help me find it. I need to know A sub 2. So I want you to notice that the n has become a 2. So everywhere in the rule, I'm going to substitute a 2 in for n. Now this works a little bit differently because if we look at the right-hand side, I didn't actually substitute a number to use arithmetically. I substituted a number to use a certain term. In other words, when I simplify, I'm going to end up with A sub 1. Well, right now, I already know what A sub 1 is. I know that A sub 1 is negative 2. So I'm going to substitute negative 2 in for A sub 1. And negative 2 times negative 2 is positive 4. So the second term in my sequence, A sub 2, is positive 4. Now this time I need the third number in the sequence. So now I need A sub 3. That means that my n is 3. So everywhere I see an n in the formula, I'm going to substitute a 3. And now if we simplify, I have negative 2 times A sub 3 minus 1, and 3 minus 1 is 2. Now, I just found out what a sub 2 was. I found out that the second term, a sub 2, was 4. So I'm going to substitute 4 in for a sub 2. Negative 2 times 4 is negative 8. So the third term in my sequence is negative 8. And the same rules apply as they did before when we were looking for a pattern in the sequence. If you can find a pattern in the sequence, you don't have to continue to use the rule. You can just finish off the sequence. But if you can't find the pattern, then you're going to want to continue to use the rule. This is a recursive definition because 1, it's using 2 different parts, and 2, we're always using the term before it to get the next term. So let's do one more. We need the fourth term. Right now we have 3, so we're looking for the fourth term. So everywhere I see an n, I'm going to substitute a 4. And then I'm going to simplify. A sub 4 minus 1 is really a sub 3. And I just found a sub 3. I know that a sub 3 is negative 8, because that's the third term. Negative 2 times negative 8 is positive 16. So the fourth term in my sequence is positive 16. Hopefully by now you've noticed that I'm doubling the numbers each time, and I'm also changing the sign. That means I'm multiplying each number by a negative 2. Negative 2 times negative 2 is a positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. And 16 times negative 2 is negative 32. Let's take a look at one more example using a recursive rule. Okay, in number 4, the first part of the rule says a sub 1 equals 1. So they tell me the first number of the sequence is 1. Because there's 2 parts to this rule, I know that I'm using a recursive rule or a recursive definition. Now this time I'm looking for a sub 2. I need to find the second term in the sequence. But if you notice, our rule starts off with a sub n plus 1, and I really want this to equal 2 because I'm looking for the second term. That means the n value has to be a 1. The reason that has to be a 1, the n is a 1, is because I need the whole thing to be equal to a sub 2. Remember, I'm looking for the second term. So n is 1. Everywhere I see an n in the rule, I'm going to substitute a 1. So a sub 1 is 1. Add 3. 1 plus 3 is 4. So the second term in my sequence is 4. This time I need to find the third term in the sequence. Now I'm not going to say a sub 3 because my rule says n plus 1. So if I want a sub 3, I really need a sub 2 plus 1 to make it a sub 3. Now the n has become a 2. So everywhere I see an n in the rule, I'm going to substitute a 2. Remember, the recursive rule uses the term prior to it to get the next term. A sub 2, in other words, the second term, is 4 plus 3. So the third term is 7. Now at this point, hopefully you've noticed the pattern for the sequence. To go from 1 to 4 and to go from 4 to 7, it looks like I'm adding 3 each time. So the next number would be 7 plus 3, which is 10. And the next number would be 10 plus 3, which is 13. As far as work goes, I should see work to find the first couple of terms, maybe at least the first two, but you're probably going to have to find the first three in order to get the pattern. After that, you can just continue the sequence without showing me the work for the rule. Okay, sometimes I'm going to give you the sequence, and you're going to have to tell me the rule, so we're going to work backwards. We need to write a general expression that represents a sub n. In other words, each term number for the entire sequence. I need to decide what the rule is going to be. Since I'm looking for an expression that represents a sub n, I want to know what a sub n is equal to. In other words, what is each term number equal to? In order to find that out, what you have to do is compare the term number itself to the term in the sequence. And that sounds a little bit confusing. So what I'm going to do is say that 3 is the first term. 6 is the second term. 9 is the third term. 12 is the fourth term. In order to create my rule, I need to figure out what I can do to this number to get that number. What do I do to this n value to get the term number? What do I do to 3 to get to 9? What do I do to 4 to get to 12? And it has to be the same thing each time. What do I do to the n in order to get the number in the sequence? Well, to get from 1 to 3, I can add 2. But adding 2 isn't going to work to get from 2 to 6. So add 2 is out of the question. To get from 1 to 3, I can also multiply by 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. So it looks like what I'm doing is multiplying by 3 each time. But what I'm doing is I'm multiplying the n, the term number, by 3. It's a little bit complicated to write the rule for a sequence. We're going to make it a little bit easier in the next couple days. But for now, what we have to do is figure out how is the n, the term number, connected to the number in the sequence itself. Let's take a look at another example. What I want you to notice is that each one of these numerators never change. So that actually makes it a little bit easy for me. I still need a rule that represents a sub n. So I'm going to say a sub n equals. All of my numerators are a 1. So I'm going to keep a 1 in the numerator because that never changed. But if I say to myself that 1/2 is the first term, and 1/3 is the second term, and 1/4 is the third term, and 1/5 is the fourth term, I want to relate this term number, this n, to that denominator, because I don't have to relate it to the numerator never changed. What do I have to do to the 2 to get a 3? What do I have to do to the 3 to get a 4? What do I have to do to the 4 to get the 5? Well, if you look at each one of these n's, all I have to do is add 1. So the rule is 1 over whatever the n is and add 1 to it. Okay, last question. Applications of sequences. We're going to have lots of word problems that involve sequences each day of the chapter. A ball is dropped from a height of 16 feet. So I'm going to start on a platform or on a building somewhere 16 feet up. Each time that it bounces, it reaches a height that is half of its previous height. So I'm going to throw the ball down, it's going to bounce, and its height is only going to be half of what it used to be. We can list the heights and the number of bounces in a table. So I start off at 16 feet, the ball bounces one time, and it goes to a height that's half of its previous height. So if I was at 16 feet, After it bounces, I'm only going to be at 8 feet because I need to go half of my previous height. After the second bounce, the height is only going to reach half of its previous, which is 4. After the third bounce, I'm going to be at 2 feet because I'm cutting the number of feet in half. After the fourth bounce, I'm at 1 foot. Fifth bounce, I'm at a half of a foot. Sixth bounce, a half of a half is a quarter. After the seventh bounce, a half of a quarter is an eighth. And after the eighth bounce, a half of an eighth is a 16th of a foot. So my sequence that I created was 8, 4, 2, 1, 1/2, 1/4, and it would keep going. The ball would just keep bouncing lower and lower and lower. Now, to write a recursive definition requires 2 parts. The first part is telling the reader what the first term is. That's the easy part. A sub 1 is 8. The harder part is finding the rule for all the terms. Now remember, with a recursive definition, we want to relate the terms to the previous ones. In other words, what do I do to 4, or what do I do to 8 to get to the 4? What do I do to 4 to get to the 2? What did I do each time? Hopefully you're saying divide by 2. So I need to take something and divide it by 2. That something is the term before it. And the way that I represent that is a sub n minus 1. A sub n minus 1 means the term before. A sub n minus 1 means the previous, let me spell that, term. A sub n is the current term, the one you're looking for. So a sub n minus 1 is the one before it. Okay, with any remaining time left in class, I want you to work on page 250, 3 through 45 by 3s. You're going to be creating the sequences, you're going to be finding the next several values in the sequence, and you're going to be creating rules for the sequence.